Hey, welcome back. We've been working through ideas in a forces unit for physics and AP physics classes and talking about tension, and now we're getting into harder tension problems where there are just too many unknowns. You're wondering how to approach these problems when you're like, holy crap, I've got a lot of unknowns here. How do I go about simplifying this? And so I'm going to talk you through how to approach these kinds of problems here. And the example I'm using is my son's old Transformer toy. A physics textbook is a swing and two bungee cords attached by duct tape here, and that makes a swing in effect. And what happens is you have a tension here and a tension here, and the question is, what are the tension values for this first tension, the second tension, and how do we deal with problems like this? So let's go ahead and get to it. First of all, I'm going to estimate the combined mass of the textbook and the transformer guy to be 2.25 kilograms, and I did measure these angles here. That's about 10.5 degrees. This is 13 degrees. So we're going to take that and approach this like it's any other physics problem, but actually a bit more difficult than standard physics problems. So let's take a look. So first of all, we're going to draw a free body diagram here. We've got three forces, tension 1, tension 2, and the force due to gravity. And I've written out my given values over here along with my diagram to help us. One of the first things we're going to do is take a vector, take a tension that is at an angle to the x or the y axis, and you're going to make that vector into the hypotenuse of a right triangle. And then we're going to solve for tension 1 of the x and tension 1 of the y. This is a little bit more difficult because we just have too many unknowns here. I'll show you what I'm talking about. We just start doing some component work here, and we can solve for tension 1 of the x in terms of tension 1, or we can solve for tension 1 in terms of tension 1 of the x. And at the beginning of the problem, we're actually not sure which we're going to need, so let's just go ahead and write them both out. We're going to continue and do similar work with tension 1 of the y, and we don't know because we have so many unknowns, we don't know which we're going to solve for. We're just going to solve for all four of these and have them handy as we do the problem. So those are your tension 1 components. Let's go ahead and move on to tension 2 components. So this is the second vector over here. We're going to do very similar things with tension 2, so I'm going to quickly show you that. That is basically the same idea here, breaking down components for tension 2. Pause that if you need to take a look at this. And then we're going to think about how to start combining these things together. So if you've seen some of my other videos, you may anticipate where I'm going with this next. The major strategy I want you to use when you're dealing with forces in a free body diagram is what I call the sum of the forces strategy. So in brief, here it is right here. You write out the first line, the sum of the forces, and then literally is the sum of the forces in that axis. So you add up those forces, and remember forces can be negative, so you're going to make that a plus negative over here. And then the second line of the sum of the forces strategy is to say the sum of the forces is equal to mass times acceleration of the x. And then you can set these two equal to each other. Remember, at that point, it's useful to ask yourself, all right, is this something or is this nothing? This acceleration right here, what do you think? Is this something or is this nothing? Well, the answer is this is nothing in the sense that it's not moving at all, so therefore it's not accelerating at all. And now we have this equation that we can work with in the x. Oh, we need to simplify a little bit more. So tension 2 to the x is equal to tension 1 to the x. That actually makes sense, right? This thing's not even moving, so whatever the forces are on the left side, balance out the forces on the right side. So of course that's true. But what we want to do is we want to substitute in terms of tension 1 to the x and tension 2 to the x. We're going to end up with 4 variables. Let's cut the 4 variables down to 2 variables. Let me show you what I'm talking about here. We're going to end up with tension 2 in the x becoming tension 2 times sine of theta and tension 1 times sine of theta. Now, I do want to point out something really important here, and that is this is the first time we've been able to relate tension 2 and tension 1. This is really important because we're going to need to substitute this equation or a variance of this equation into future equations. I'm going to go ahead and mark this with a happy face. This is a long problem with a lot of complex thinking going on, so I'm going to make that happy face visible. And I will show you where I sub that in. This is another happy face equation here because it's really important. So we will take those happy face equations and sub them in later in the problem. I just want to make clear reference to them so you know where I'm getting these equations from. Alright, well let's continue. We've done the sum of the forces in the x. Any guesses as to what we'll do next? Well, we're going to do the sum of the forces in the y, of course. So we will write out the sum of the forces in the y and literally sum up the forces in the y-axis. The second line of the strategy is to write out Newton's second law, and then we set them equal to each other and see what happens. So this is what we have. Then we ask ourselves, all right, is this something or is this nothing, this acceleration of the y? What do you think? In this case, the acceleration of the y is nothing. It's not moving the y at all. This point right here, it's not moving at all, so therefore it's not accelerating at all. So that whole term drops out. And then we can start to isolate for things we know and don't know. Normally I put the unknown by itself. We actually have two unknowns, so I'll put both of them, I guess, on one side. We can figure out the force due to gravity, but both of these we don't know. But notice there are two vectors in terms of y. So what we can do is actually sub in what we did previously for tension 2y and tension 1y in terms of tension 1 and 2. So let's go ahead and do that. So I've now substituted in what I had done previously for tension 1y here, and tension 2y here. I'm going to call this equation 1, so when I come back to it, you know what I'm talking about on the next page. Same equation up here. And next, what we can do is substitute in. So we have T1 over here, T2 over here. We want to reduce the number of variables that we have to work with. That's the name of the game for these kinds of problems. You always want to reduce the number of variables that you have if at all possible. So I'm going to put it in one of those happy face equations over there. This is what T1 was equal to previously. So I've subbed that in. And now notice this is the beginning of the end, so to speak, because I've only got one variable here, T2. It's also over here. And that's it. Everything else is good. So I'm going to start isolating for T2. That's what I'm doing here. I'm going to label this as equation 2 just so that when I go to the next page you know what I'm talking about. Here we've got T2. We do some more algebra. Now we can plug in our numbers and we end up with our answer for T2. That's gold. Once we get that, then we can take that and plug that back into one of those previous equations and solve for our other unknown, which is T1. So we go about doing that. We can sub that in. Here's what we had previously solved for T2. Now I can go ahead and plug that in over here or plug it in over here. I'm going to choose to work with this equation because this is already isolated. And so when I do that, I've got that 10.1 here and I continue with the math. I end up with tension 1 being this value over here in terms of our newtons. So that's how you go about solving a problem like that. That is more difficult than a standard tension problem. You would have multiple unknowns to deal with, but that's essentially how you would tackle one of these problems. I do want to mention I've gone over all of the major concepts more or less for a year of physics, and I'll put a link to the description below of some of those units that you can take a look at, and I'm in the process of doing the same for AP Physics C mechanics as well. And if you have any comments, please let me know down below, and I hope you all have a great day. Take care.